Okay, in this next problem, it's the same student as we dealt with before. Recall from down here, so I'll show you, we had the student underneath the street light, and we had to figure out how tall the street light was. So here it's the same street light and the same student, but this time the student's moved so that their shadow is twice as long as they are tall. So they're 4 feet, that means that the shadow is 8 feet. And we're asked to figure out this time how far away do they need to stand from the street light in order to make that happen. And the street light is still the same, 16 feet. So this time we're doing something very similar. Again, I'm going to superimpose my problem onto a coordinate grid. I've got point A, which is 0, 0. I have point B, which is 4, 2. Now here I have point C. Now this time I know the x-coordinate for point C because I can just. Oh, no, I'm sorry. I know the y-coordinate for point C. It's 16. What I don't know is the x-coordinate. The x-coordinate will tell us how far out the street light is, and then we just have to subtract to find how far away the student is from the street light. So take away these first 8 feet. But we're going to follow the same process. So I'm going to write the equation of a line, and then we'll use that line and plug in the y-coordinate to find the x. So first, find slope. Alright, so let's see. So change in y, end minus start. 2 minus 0 is 2. Change in x, end minus start. 4 minus 0 is 4. So change in y over change in x. 2 over 4, which reduces to 1/2. Next, write the equation. We're going to use slope-intercept form, mx plus b, because we know the intercept. So y equals 1/2 x, and the y-intercept is just a 0, so we can leave off that entirely. Now, we're going to find c, and we're going to use our equation, y equals 1/2 x, and this time instead of plugging in an x, we're going to plug in a y, because we know the y-coordinate for c. We know that it is, we'll call it x sub c, comma, 16. Right, because the street light's 16 feet tall. We determined that in an earlier problem. We just don't know how far out it is. So we'll replace y with 16 equals 1/2 x. Divide both sides by 1/2. You can always use your calculator for this, or you could remember that dividing by 1/2 is the same as multiplying by 2. So that gives us 32 equals x. Now we found the x-coordinate for point C is 32. Let's just make a note here. That is 32, 16. But that doesn't tell us how far away he's standing because we have to take away. That tells us that this right here is 32 feet out. So this point right here is 32, comma C, or 0, sorry. But that doesn't tell us how far away the boy is from, or girl I suppose, is from the street light, because we have to take off this original 8 feet. So we'll say find D, because I've labeled D right there on our diagram. And it's just 32, take away 8, which is 24 feet. Okay. Now we're done. So again, just to go over the process, so we drew a picture of our problem here. We noticed that the base of the shadow, the height of the boy, and the street light are all collinear. So we superimpose the whole thing on this coordinate axes. I knew the coordinates for A and B, and we knew the y-coordinate for C because we had that from an earlier problem. So if we have to write an equation of a line that passes through A and B, and use that equation to find the x-coordinate for point C. To write the equation of the line that goes through A and B, we first had to find the slope. Remember, slope is change in y over change in x, and we're calculating that change in y and the change in x it's end minus start equals change. So we take the ending y-coordinate and we subtract the starting y-coordinate. And we could go either direction, by the way. You'll end up with the same answer as long as you choose the same point as the start point and the same point as the end point for both change in x and change in y. So you can't go in one direction for y and one direction for x. Anyways, once we have the slope, we wrote the equation. We used slope-intercept form because I know the slope and I know the intercept. So that was y equals 1/2 x. And then, since we knew the y-coordinate for the point, we just substituted 16 for y and we solved for x to get 32. So the coordinates for point C are 32, 16. But of course that didn't tell us what the distance was to the student, because we have to take off the 8 feet that for the shadow first to find this distance d. So finding d was 32 minus 8, or 24 feet. So the student needs to stand 24 feet away from the street light in order to have a shadow that's twice as long as they are tall.